Hello everyone, welcome to my your programming club. Today we will be solving another daily LeetCode problem, and the problem's name is minimum swaps to group all ones together, part 2. So according to the problem statement, swap is defined as taking two distinct positions in the array and swapping their values. Okay, and the array that is given to you will be a circular array. By circular array, it means that the array is something like this. If let's say this is the start of the array, so it is meeting the end of the array. Okay, so if this is the start point, so the very next point on the this side will be the end point of the array. So circular array will be kind of this. Okay, I hope you are able to understand. Now where we consider the first element and the last element to be adjacent, as I already shown you. Okay, so yes, as you can see, the start and the end point are adjacent in this particular one. Okay, so given a binary circular array, binary means it will be having only values of zeros and ones. Return the minimum number of swaps that will be required to group all the ones present in the array at any location. Okay, so you have to perform minimum swaps and you have to group all the ones present in this particular array in one location, and you have to achieve that with minimum number of swaps that will be possible. Okay, so let's have a quick look at the constraints also before thinking of an approach. So according to the constraints, length of the array will be of order 10 raised to power 5, and each entry is either 0 or 1, as it's already mentioned in the above statement also that it's a binary array, so each entry will be 0 or 1. Okay, so now coming to the problem, let's pick one of these examples and try to understand how we can solve this particular problem. Let's pick our example in which there will be the case for this start and end points to be adjacent. Okay, so that should be taken into consideration while solving. So the third will be the a good example, I think. Okay, or for simplicity, let's take the very first example. Let's try to understand what's going on here, and we will consider the circular nature of the array in a little bit further down the line. Okay, so let's take it to the board. So this is the input array that is given to you. Okay, so there are some observations that are needed to be made in this particular example or in this problem in general. What are those observations? The observations are the number of ones that will be grouped together will be this is obvious observation, although I am writing it just for the sake of clarity, equal to ones in the array, given array. Okay, number of ones in the given array. Okay, for now we are considering that this array is not circular. Okay, just for the sake of understanding the core logic here, and then we will consider the circular scenario also. Okay, so the second observation is that how many number of replacements are needed to be done. Okay, so the number of replacements that will be needed to done will be, so the number of swaps that will be needed will be in the subarray of size, let's call this a number. Okay, so one count can be, it can be called, okay, one count. So the in the subarray of size one count, okay, the number of zeros that are present will be the number of swaps that we have to make in that particular subarray. Okay, so the number of zeros present will be equal to swaps that we have to make. Okay, and we will be considering all the subarrays of size one count that can be formed. Okay, then the third observation is, let's change the color here, count, or not count exactly, consider all the subarrays or all such subarrays of size equals to one count. Okay, the reason of being reason of taking this subarray of size one count is that it will be equal to the number of ones in the array, and since we are required to make all the ones together, that's why it is wise to have such a subarray, because at the end your end result will be looking like this, all the ones grouped together and there is no zeros in between them. So if there are some zeros in a subarray of size one count, then those zeros are needed to be replaced with ones. Okay, and those will be the exact number of swaps that will be needed for that particular subarray. Okay, and we will consider all the subarrays of size one count that can be formed with this particular given array. Okay, so this is the third observation and the last observation, and from among all the subarrays, or you can take the very last observation also if you want to further, you know, make it into parts. So from all such subarrays, find the one which is needing minimum replacement or swaps, and that is it is having minimum zeros. Okay, so this subarray, to consider all the subarrays of size one count in the given array, what we can do here is we can have a window like structure. So what I mean by this window like structure is, you will be having a window, let's say there were three ones in the given array, so that's why we will be having this window like structure of size 3. Okay, so and you will slide it by each time by one position towards the right. Okay, so right now it's the initial position of the window, and you will be counting how many number of zeros this particular array is having. Okay, so this particular array is having two zeros, so two swaps will be needed. Okay, two zeros translates to two swaps, because you need to bring in two ones to make all ones together in this particular subarray. Okay, so that's the whole logic of this method or approach. Okay, so now we will move our subarray to one step towards right. Okay, so it will be looking something like this. Now it shifted to one step towards right, and while we were shifting, we will check the entry just that we have just moved past was 0 or not. If the entry was 0, then we have already seen two zeros, and we will subtract one from it, because the previous entry that we have just left in from the current window, it was a 0, so that is needed to be excluded. That's why we are subtracting 1. Okay, so that is what we are doing here. Okay, and this whole procedure of doing so will continue till your this end of the window reaches here. Okay, or this, there are no more elements to move further to. Okay, this window is moving one step at a time towards the right direction. Okay, and at each time you can very easily find the number of zeros in this way, and then you will be returning the minimum zeros that were there in any subarrays. Okay, and those will be the number of minimum swaps needed. Okay, this is for the scenario in which the array is not circular. Okay, not circular. Okay, and what if the array is circular? Okay, so there might be a scenario. Let me draw this, that scenario. Okay, so your subarray might be wrapping around some part of from the right hand side and some part from the left hand side, because the last and the first element were adjacent due to the circular nature that we already discussed about, like this. Okay, so there will be a situation that subarray is having something like this space in the array. Okay, some part of the start is involved from left hand side, and some part of the end is involved from right hand side. Okay, so there, this kind of situation can be there. So what, how you will tackle that situation? So that is the whole scenario of the circular array. Okay, so in that kind of situation, what you can do is, instead of trying to make all the ones together, why not make all the zeros together? Okay, try to think about it. If you make all the, consider a scenario where you have to make all the zeros together, and do not consider it as a circular array at all, then this circular array situation will be covered easily. Okay, and how so I am saying that? Let's take the third example for that to the board. Okay, so this is the third example, and let's take a fresh slide also. So let's copy it here. Okay, yeah, now it's fine. So what kind of situation we were talking about of the circular array? This window place in circular array, the situation was like this. This window might be having some parts from the start and some parts from the end. Okay, you can draw it like this also if you want, if you want to have a clear understanding how things are going out. So this was if you consider bringing zeros together, so the number of zeros 2 in the subarray, in the whole array. This is the given array, by the way, and let's not consider the circular nature at all. Okay, so we are just worried about bringing zeros together. Okay, so these zeros are already together, and when the subarray of this window will be sliding to this position, you will get to know that the number of swaps that are needed here are 0. Okay, 0 swaps needed because there are no ones in between them. Okay, if you are trying to bring zeros together, so there are no ones, so that's why 0 swaps. So as you see, if the array was circular also, in that condition we were also needing 0 swaps. So instead of bringing ones together, you can try to bring zeros together to uh, you know cover the scenario of the array being circular. Okay, so this is what we need to do for the circular consideration of the array. And yeah, then we can simply return minimum of these two scenarios. What two scenarios? The first scenario is bringing ones together. This was for the situation where the array is not considered to be circular or linear array case. Okay, and to account for the array being circular, you can bring one zeros together. Okay, so this will be account for the array to be circular array. Okay, so you will take minimum of these two cases. Okay, so this will be returning you some number of swaps that will be needed. Okay, so you will take minimum of these two and simply return it as your answer. And now let's have a quick look at the implementation. Although the implementation is exactly what I have told you in the approach, but still we should have a look at it. And let's try to understand what's going inside the code that we have implemented for this approach. So let's take a fresh slide again. So let's zoom in a little bit. I think this should be fine, and we can definitely break this down further and add some space to it. Yeah, this should be fine. And let's discuss what's happening inside this particular code. So as we discussed, we need to account for consider two scenarios. The first scenario was bringing ones together, or one of these scenarios was bringing ones together, and the second scenario was bringing zeros together. Okay, so first of all, we are considering the scenario of bringing zeros together, and then we are considering the scenarios of bringing ones together, and whichever of them is giving you minimum swaps, that will be your answer. Okay, and for each of the scenarios you will be trying to find the minimum swaps that will be needed. And the technique of sliding this window of size, one count or zero count, whatever case you are encountering, is called sliding window. Okay, and those of you who are not familiar with this technique, although it's nothing fancy here, we will be just using a couple of pointers. One will be pointing to the one end of this uh, sliding window, which will be called, let's say, left, and the another one will be pointing to the other end, let's say it is called right. Okay, these will be maintaining the state of the window. Okay, or the place the window is currently at in the original array. So anyways, I will also provide a link for it. A link of an article will be provided describing what and is sliding window and how to apply it and when to apply it. Okay, so now coming back to the problem. uh, so then what we will do, this is nothing but a implementation of sliding window. Okay, first of all, you should be knowing that whatever the value that you are favoring to make together, what is the count of that value in the given array. Okay, so let's call this value count. If the value is 0, then it will be 0 count, and if it's 1, then it will be 1 count. Okay, so once we are having that count, we know what size of window we should be sliding over the original array. Okay, so window size will be set to that count. Okay, I hope till now it's clear. And as I already discussed with you, that left will point to the one end of the window and right will point to the other end of the window, and initially the window is shrinked. Okay, so this is left and this is right, and both of them are pointing to the same direction. You should inflate your window to the desired size, and once it's having the desired size, then you can slide it over the array. To inflate the window or make it to the desired size, this loop is for that, to achieve the desired window size. Okay, and while doing so, we will also take into consideration what are the opposite values that are encountered. For example, if you are considering the case of bringing ones together, then the opposite value will be 0. Okay, and if you are trying to consider the case of bringing zeros together, then the opposite value will be 1. Okay, so I hope till now it's clear. Then we will also count the opposite values along the way of making this window of the desired window size. Once we have achieved the window size and along the way also counted the opposite values in the current window or the initial window after it have achieved the desired window size. Okay, then we will be sliding this window down the original array, moving it one step at a time towards the right. Okay, and this is just the element that we have just left. If the element that we have just left, which was earlier the position of the left pointer, you can visualize it here. So this was the earlier element that we have just left, and this was the earlier position of this left pointer. Now left pointer is shifted to this position although, but if that position, earlier position that left pointer was pointing to, uh, was a opposite value, then you will say that we should decrement the number of opposites value, because we have left that value and it's no longer part of the window. So that in that case we will decrease it, and then we will be also moving our right pointer one step ahead. So this right pointer will also be moving in this direction. So if it is encountering a opposite value, then you will increase the number of opposite values in the current window. Okay, so in a way you are always having the correct amount of opposite values in the current window size, and window size is nothing but which is equal to value count for the values that you are trying to bring together, the count of those values in the original array. Okay, and then you will find minimum opposite values, or which will be equal to the minimum swaps. Okay, or you can say minimum swaps. Okay, in all the subarrays that you will be considering of size, window size, while this window is sliding down the array. Okay, and you will be returning that, and as we already discussed, we need to consider these two scenarios, and whatever scenario is returning as minimum number of swaps, we will be considering that one, and that will be our answer. I hope everything is clear to you. If you are still having any doubts or any queries in general, you can definitely ask them in the comment section, and prefer to ask the comments to the doubts in the videos comment section, because I actively look for the comments that are being made to the videos, and it gives me notifications also, and that are quite easy to follow. Okay, so uh, now before ending the video, let's have a quick discussion about the complexities also. Okay, and let's take a fresh slide for that. The time complexity wise, as you must have seen, we are just doing some linear traversals here, couple of linear traversals, Other than that, we are not doing anything else. So time complexity wise, it will be order of n, where n is the size of the given nums array. Okay, this will be, if this is the array of size n, then your time complexity will be order of n, and you can say linear. And space complexity wise, as you must have seen that we are not using any extra space here, just using variables to maintain the windows state also, left and right. So it's constant here. Okay, so linear time complexity and constant space complexity, and these are the complexities. And I really hope you are able to understand this approach, and this solution we walk through added some value to your journey of honing your DSA skill. And until next time, keep solving more and more problems, and I will see you in the next video. Thank you for watching.